All right. Well, again, I hope there are no questions, comments, problems. But if there are after you've watched this, then let me know. Email, phone, WebEx, whatever. Drop in. Let's talk about it. Okay. So let's see where else we're going to go. So some sample questions. Define entropy. So entropy is a measure of the disorder in a system. Spontaneous occurs with no intervention. I.e., it's going to happen unless I take some step to make it not. Is it enough to know the enthalpy of a reaction to know if it's spontaneous? So what do I mean by that? So if I know that something is exothermic, is that always going to happen? The answer is no. Okay? So no, enthalpy is not enough. Is the entropy enough? Well, no, I don't think it is. And of course, I'm telling you that, so it's not. Both of these are factors that we have to consider. So just having more, disorder in my system doesn't necessarily guarantee that that's what's going to happen. Sometimes we make order. It happens. But we have to have the conditions which can allow that to occur. Okay. So that's not the only thing that we have to look at. Okay. Consider the following reaction. N2 plus 3H2 goes to 2NH3. Delta H is negative 92.4 kilojoules per mole. The absolute entropy values S at 238 Kelvin for N2, H2, and NH3 are 192, 131, and 193, respectively. Calculate delta S for the reaction and explain the sign. Okay, remember that delta S is equal to the sum of the number of molecules times the delta S for the products minus the sum of the number times the delta H of the reactants. Okay, so in this case, since I'm going here, I have my NH3 as 193, my N2 is 192, and my H2 is 131. So those are the values that I was given in this question below. Okay, so calculate delta S. Well, okay, my products, I have two of them, and that's 193. And then subtract the 192 times 1 plus 3 times the 131. Okay, so 2 times 193, that gives me 386. And subtract 192 plus 3 times 131, which is 585. And it gives me negative 199. And of course, that is in joules per Kelvin mole. Okay. Now, calculate delta S naught for the reaction and explain the sign of the delta S naught. All right. Well, so this is not, and I've left it as kilojoules per mole because we actually make 2 moles here, so that's why we have that. But it's negative. Okay. That means that I've gone to a state that has less entropy than when I started with. And looking at this equation, that makes sense to me because the total number of moles of gas on this side is 4, and over here is 2. So I have less disorder when I have 2 moles of gas than I do when I have 4 moles of gas. Even though I have more because they're bigger molecules and they have more bonds and there are more ways that I can arrange them, that factor is less of a contributor than the number of moles of gas. Okay, so that's why it's negative. Okay, so it has everything to do with the change in the number of moles. So questions, comments, problems about that? Hopefully not. All right. Now that's going to take us to our entropy in class practice. All right, and I'm going to set up for that in just a second. I'm going to go ahead and stop here and I will be back with you in just a moment. Thanks, guys.